as you start to graph lines, you'll notice that every graph looks different, whether it comes to the steepness of the line, which direction it's going in, where it intersects the y-axis. If you look at these two examples here, this green line looks nowhere close to the purple line. It's going in a completely different direction. It's not as steep, and it intersects the y-axis at a different point. So the two main factors that control these are the slope and the y-intercept. And oftentimes, you'll be asked to calculate these, whether it's from a graph, like so, from a table, or from 2 points. So today I'm going to be showing you how to do that. Oftentimes, you're going to be asked not only to calculate these values, but to put them in an equation. And if you watched my last video, you should remember the slope-intercept form, which is the most common form of linear equation that there is. The two other forms being point slope form and standard form. Those will be touched on in a later video. But basically, in slope-intercept form, which is y equals mx plus b, the m is the slope and the b value is the y-intercept. Now, what is the slope exactly? So the slope controls how fast the line is increasing over a certain period of time. The slope is also commonly referred to as the rate of change or even the proportion over a distance. And the direction of a line is controlled by whether the slope is positive or negative. So if the slope is positive, you'll see the graph being increased from left to right, like this green one. And if the slope is negative, you'll see that the graph will go and decrease from left to right, like this purple one. And what is the y-intercept? Well, it's simple. It's where the line intersects the y-axis. And in the y-intercept, which is really just a point, the x value is going to be 0. Because when the x value is 0, that's when you're lying right at that y-axis. Now, let's ask ourselves, how can we calculate slope? And the main formula to calculate slope is m equals delta y over delta x. Now, you're probably wondering, what the heck is this? Why did this dude write a triangle here? Well, the delta, which is the name of the Greek letter that this triangle actually is, the delta means change in. And so slope is calculated by a change in the y-coordinate between two different points over the change in the x-coordinate between those same 2 points. This can also be written as y2 minus y1 over x2 minus x1, or you could literally just write change in y over change in x, but we're going to be referring back to this one because this is the most efficient way to write this formula. So that's how to calculate the slope. And when you're looking at a graph, the way to calculate the y-intercept is very easy. You just look where the graph intersects it. Now, say the graph were to intersect it at an sort of abstract point, like 4.766, and there's no way you could find that by just looking at it. Well, that is something I'm going to touch on later in this video when we go to something like from 2 points, that you're going to plug something back in to get that b value. But first, let's just look at this green line and practice calculating slope and y-intercept from it. So the first step, like I said, was calculating delta y over delta x. And you do this by looking at two different points in the graph and then looking at the change in y coordinates between those points and dividing that value by the change in x coordinates over those 2 points. So we already have 1 point on this graph that I've plotted, and it's at 0, 3, correct? I'm going to write it on the side here, 0, 3. And that's the y-intercept. We can use that towards finding the slope. And let's look at the other point, another point that we could put. We could really put it at, how about 2, 4? This looks like the cleanest. This coordinate plane is a bit weird. There's a space here, so, well, there should be like squares here, but they didn't put it. So you could imagine that this is still going on the same path, I suppose. Yeah. So our points are 0, 3 and 2, 4. Now when you're looking at a graph instead of calculating the differences, you might want to visualize the differences. So first, let's look at the change in y. And usually you're going to want to start from your first point and then go to your second point. So if you start from your first point, you're going to see that the change in y is going to be, let me make my pen a little thinner. And the change in y between these 2 points is going to be just 1. Okay? So delta y is going to equal 1. And now if we go and try to find the distance in the x coordinate between these two, we will see that it's going to be 2 units. So the delta x is going to equal 2, right? And when we refer back to our equation m equals delta y over delta x, we can plug these values in and we will get m equals 1 over 2. Remember to put the delta y over the delta x, and that's basically your slope. You've gotten it. Your slope for this green line is going to be 1/2. So if we were to write this out in an equation, because oftentimes your teachers are going to ask you to write out the slope and y-intercept after calculating them from whatever you're calculating them from into an equation. So that's what we're going to do right here. Y equals, going back to our slope-intercept form, 1/2 x. And then now the only thing left to write or find is our b. But really we've already found that. We see that the line intersects the y-axis at 3, or 0, 3. So the y-intercept is going to be 3. And that's going to be our b value for this equation. So we see that this line, this green line, corresponds to the equation y equals 1/2 x plus 3. So now let's do the same thing for the purple one. If we were to do the same thing, we could use 2 simple points. So we see that one of them is at 0, -1. So we already know that because it's intercepting the y-axis at that point is the y-intercept. And we can use another clean point like 1, -3. And now we can calculate the differences. So once again, let me make my pen a little thinner so we can draw the dotted lines. And you want to start with your first point. You could start with either really, but if you were to start with this one and then to go up, then it would be positive. And then if you were to travel a distance of left, your delta x would be negative, right? So this line is looking to decrease from left to right, so we already know our slope's going to be negative. Because our slope's negative, we know that one of these values, delta y or delta x, is going to be negative anyways. So you could start from either, but I like to start from the uppermost, or rather just the first point. So looking for change in y first, we see that the change in units is going to be -2, because the reason why the delta y is -2 is because we're traveling downwards. If we were to travel upwards and go from this point, then the change in y would be +2. So remember, down negative, up positive, and also left negative. If we were to travel left, it would be negative, and then if we were to travel right, it would be positive. And that's fair. That applies to the x. So we see that it's downward, so negative, and delta y is going to equal -2, right? And we can go right to make it to that point, and we see that right 1, that's a change in x of 1. So delta x is going to equal 1. Okay? So going back to our formula, m equals delta y over delta x, we can do this calculation easily. So m equals -2 over 1, and that's basically the same thing as -2. So we know that our slope for this line is negative 2. And we already established that our y-intercept is at negative 2, right here. So knowing, oh no, sorry, not negative 2, negative 1. So now we can form our equation, which is going to be, oh my goodness, what is happening? Okay. Now we can write our equation, y equals negative 2x minus 1. And we put minus 1 because the y-intercept is at negative 1, not positive 1. And yeah, that's basically how you get slope and y-intercept from a graph. So I'm going to show you a little shortcut that I like to use if you're dealing with lines that cross, that have like a whole number slope, right? So I like to look at the number of squares on the grid, like these squares that the line crosses before reaching the next point, right? So you could also think about it just by looking at the lines, and you see that, oh, it just goes right one line and then it goes down 2 lines. That means knowing that it's a slope of negative 2. But you could also say, oh, it's going 2 squares down and 1 square across. Because of that, I know that we're dealing with the slope of negative 2. Or for this one, it's going 2 squares across, but it's only going 1 square up. So that means it's doing 1/2. And we know this because it's intersecting the gray midline in the middle, right? That explanation was probably a little confusing, but as you get more and more used to finding slope from looking at a graph of a line, you'll start to notice these patterns of the squares, and immediately upon looking at the line, you can say, oh, I see this green line. I know the equation is y equals 1/2 x plus 3. Or you can look at this purple line and say, oh, it's going this direction. I see that it's going this number of squares down to get to its next point. And now I know that the slope is negative 2. So y equals negative 2x minus 1. So as you become more accustomed to finding these slopes and y-intercepts, you'll sort of get these habits in your mind to do things like this. Alright, now let's move on to getting equations from the table. And really, you're applying the same concepts here, except you're not seeing it visually, you're looking at it in a table. The way to do this is you're still using that same equation, m equals delta y over delta x, but instead you're finding the differences between the points given a table. So I feel like it's a little easier to do this when you use that formula. So if we look at these 2 points, negative 2, and negative 1, 0, we can start to form, or we can calculate the differences between the y's and the x's. So we can see that the difference in y when going from negative 2 to 0 is positive 2 from that point to this point. And then the difference in x right here is positive 1. So this is going to be our delta y, and this is going to be our delta x, right? So if we apply our formula, we'll do m equals 2 over 1. We see that our slope is equal to 2. Now, if you're doubting that this will work for any 2 points, we're going to try that. We're going to try the same thing for 2 other points. So we see we have negative 1, 0, and I'm going to skip over the 3, 8 so that you know for sure that it'll work with any 2 points. They don't have to be successive. They don't have to be right after one another, even though it makes it a lot easier if they're right after one another. But it'll work with any 2 points on that line. So if you look at the differences between these, we see that 0 to 10, that's a plus 10 difference. and then negative 1 to 4 is a plus 5 difference, right? And if you were to do the same thing and do m equals change in y over change in x, which in this case is 10 over 5, you would see that the slope would still equal 2. So this slope will stay constant throughout the entire graph's lifespan, however infinite that may be. But now we have to figure out, well, how are we going to find the y-intercept, right? Because we have to write the whole equation. And this would be a lot easier if the y-intercept was stated literally in the table. So if you saw like a value, if you saw that an x value was 0, and then you saw a corresponding y value, you would already know that that corresponding y value was the y-intercept, and you could already write it in an equation. But in this case, we don't see that, and there's no y-intercept stated explicitly in the table. So there's a way to calculate this. And the way to do it is, first you write the beginnings of your slope-intercept equation. So you write y equals, and we know our slope is 2, so 2x, and then in place of the y-intercept that we don't know, we leave b. Now, I want you to pause the video for a few seconds and try to predict what I'm going to do here, and then resume. Okay, so assuming you've paused and gathered your thoughts together, we're now going to do this. So what you do here is you take any point in the graph, like its x value and its y value, and you plug these back into the equation. Once you plug these back into the equation that you formed, the slope-intercept equation, then what you can do is you can solve the equation for b. So what we're going to do here is, let's take the point, for example, negative 1, 0. So the y value is going to be 0, so for y, we're going to plug in 0. And then for x, we're going to plug in negative 1. So 2 times negative 1 plus b. Now we can evaluate, and we see that 2 times negative 1 is negative 2. So we'll break this down some more. 0 equals negative 2 plus b. And the final step is to isolate b. So we're going to add 2 on both sides. And after doing that, we get the answer b equals 2. I flipped them because it looks more aesthetically pleasing when the variable's on the left side, but it looks like that to me. But so the y-intercept in this case is going to be equal to 2, as we got from this equation. And after doing that, now we can finally complete our equation for this table, and we can say that y equals 2x plus 2 is the official slope-intercept equation for this table. Okay, so now we're going to move on to finding the slope and y-intercept given only 2 points. Now, you've basically been doing that this whole time. If you look back to the graph, you looked at only 2 points and found the differences. If you look back to the table, you looked at only 2 points and found the differences. So don't be stressed by this, because it's really very easy in concept. So as always, we're going to find the difference between the y's and then find the differences between the x's, or the difference between the x's, sorry. And then we are going to divide the delta y over the delta x. So we see that when we look at the differences in the y's, from the 3 to the 6 is a plus 3 gain, since you add 3 to 3 to get 6. And for the differences between the y's, the x's, that is also a plus 3 gain, because 2 plus 3 is 5. So this is the delta y, and this is the delta x. Now we can calculate the slope. So m equals delta y over delta x, so 3 over 3. And it's nice and simple. We get a slope of 1. And now, to find the y-intercept, we can recall the strategy that we used back here of plugging one of the points back into the equation to get that y-intercept. So y equals 1x, so we can just write x, since there's always that invisible 1, and the slope is 1, x plus b. And now we can use either of these points and plug them back into the equation we just formed to find that b. So let's do just that. We can use, I'll use 2, 3, and substitute the 3 in for y, because the 3 is the y coordinate, and then substitute in the 2 for x, because the 2 is the x coordinate. Very easy stuff here. And now, final step, subtract 2 both sides, and you get 1 equals b, or you can write it like b equals 1. And that is our answer for the y-intercept. And for our final answer, I'm going to write out the actual equation, and it turns out to just be y equals x plus 1, substituting the y-intercept in for b. So yeah, that's basically it. That's how you calculate the slope-intercept equation from graphs, from tables, and from 2 points. I hope you find this helpful. In the next video, we're going to go more over these linear equations, and we're going to be looking at the other 2 forms, which are point slope and standard form. You'll much more commonly see standard form. You don't really see point slope that much nowadays. But yeah, thank you for watching, and I'll see you in the next one.